Chapter 6, Section 5, Slope. This is the master video, so we're just going to expand a little further on our work with slopes from the previous video. What we're going to do is we're going to determine what happens when you try to find the slope of a line, but you use different points. Okay, so we have the graph of a line, and we have 2 points that are indicated, and it wants us to find the slope using these 2 points. Okay, so this is just a review from last day. So I'm going to do it in one shot though. So we know that slope is equal to delta y over delta x. Okay, so our delta y, that is our vertical change. So I go up, so that's a vertical change that's positive. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over to the right, 1, 2, 3, 4, 5, 6. There you go. It's 90 degrees. So to the right, that's positive 6. Okay. Now normally I like to work down, but I can get away with working to the right if I'm careful. So the slope is 9 over 6, but I reduce if possible. That gives me 3 over 2. Okay. So it's positive, which makes sense because it's going up from left to right. So that should be review from last day. But the next part, it says determine the slope, but instead of starting at the leftmost point, which is right here, start at the rightmost point. What do you notice about your answer? All right, so let's try that. I'll erase this, and I'll do this one in red. Okay, so I'm going to go from one point to the other, but I'm actually going to start at this point and see what happens. So my vertical change, in this instance, I actually have to go down. Let me think, uh-oh. Right. So I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. But because I'm going down, okay, my vertical change is negative 9. But now, to get to this left point, I don't go to the right, I have to go to the left. 90 degrees. Well, I have to go left 1, 2, 3, 4, 5, 6. But because I'm shifting 6 spaces to the left, my delta x, or my horizontal change, that is also negative. Okay? Well, you should know that a negative divided by a negative is positive anyway. And this still reduces the same way. So lo and behold, we actually get the exact same answer. So it really doesn't matter which point you start at. By convention, we typically like to start at the leftmost point just because, well, for some people it's easier, but as long as you're consistent, it actually doesn't make a difference because a negative over a negative is a positive anyway. So as long as you're consistent, do whatever works best for you. All right, lastly it says select 2 different points on the line and determine the slope. What do you notice about your answer? Okay, so we're just going to do this exercise again, but I'm going to select 2 different points. And you don't have to choose the same points as me, but I'll choose this one because it's easy to read, and this one. So they're quite far apart, but they're still on the line. Okay. All right, so let's determine the slope. So we need the vertical change. So I'm going to go left to right again. So I'm going to have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And then I'm going to have to go to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So my slope is a rise of 15, so that's up, that's positive. And I'm going to the right, so that's positive. But you always reduce fractions whenever possible. So the greatest common factor between 15 and 10 is 5. So dividing both of these by 5 gives us, what do you know? 3 over 2. So what I hope is clear from this example is that if you have a straight line, it does not matter which 2 points you choose to figure out the slope. So when you're trying to do this on your own, it might be beneficial to pick the two simplest points, points that are closer together or points that are just easy to read. Because as long as you pick 2 points that are precisely on the line, it doesn't matter, your slope will always be the same. Okay. Now I didn't do this in any of the previous examples, but if you think this will help, at least in the early stages, when you're actually drawing this right triangle, feel free to give the dimensions here, to actually label it. So this was the delta x that I had here. So that was 10. And this was the delta y. So it's just the height of the triangle. And that was positive 15. Okay, so feel free to label your delta y and your delta x on the graph if it helps. But again, either way, any 2 points on the line, your slope is the same. All right, so we're going to get into calculating slopes algebraically. So far we've been doing them graphically. That's pretty straightforward if your points are close together and you're able to count grids on a graph. But if you look at this graph here, the points are quite far apart. And there are no grids to count. So we need to come up with a different technique on how to determine the slope of the line crossing between these 2 points. So there's a formula that's actually an extension of what you've already seen. So we already know that the slope is the vertical change in y divided by the horizontal change in x. In other words, rise over run. What that means is, if I just have some graph, and I have a point here and a point here, just to pretend. I'm going to label this point here and this point here, not using numbers, use letters. So this is, call this x1, y1. And I call this x2, y2. Okay, so these little subscripts just tell me which pair I'm looking at, the first pair or the second pair. All right. Now, when we found the slope of the line passing between these points previously, we were able to draw a right triangle and we just counted squares. Unfortunately, we don't have squares to count. So instead of counting squares, all we have to do is figure out what is the change in height by subtracting the top y value minus the bottom y value. And if we want to figure out this distance here, we just take the rightmost x value and subtract the leftmost x value. So that means delta y is y2 minus y1. And delta x is x2 minus x1. So that is a formula. Let's use it. All right, so let's calculate the slope of the line passing through these 2 points. So first of all, we need to label these points as x1, y1, x2, y2. Though technically it doesn't matter, I usually like to pick the leftmost point as my first set, but as long as you're consistent, the math will actually work out either way. So slope equals y2 minus y1 over x2 minus x1. Again, this is just delta y over delta x, but we can't count squares this time. Okay, so what is my y2? I'm going to label it. I'm going to call this the 2's. Doesn't want to write very well. And I'm going to call this the 1's. I invite you to switch them around and do the math and see what happens. All right. So, what is y2? Well, that is negative 24. And I subtract y1. What is my y1? That is 76. That is all over x2, which is 57, minus and my x1 is negative 68. So I'm subtracting a negative, so you have to be careful. Okay, so that's going to give me negative 100 over positive 125. Because when you subtract a negative, it's the same as adding. So there's our slope. And whenever possible, if we have a fraction, we reduce. So I'm just going to shift up here. Though these are big numbers, both of them are clearly divisible by 25. So this gives me negative 4 over 5. That's the best we can do. If you want, of course, you can put the negative sign in the middle. It doesn't matter. Okay, so without counting squares, using a formula, that's the slope of our line.